Everyone at home, we're going to do the soda can lab, and it starts out with an empty can. So we're going to tear the scale out, and Mr. Spears is going to put 20 grams or around 20 grams of water into the can. Now, the amount of water we're putting in here doesn't have to be that specific because we're just going to boil it, okay? And when we boil it, a bunch of water is going to come out the mouth of the can, so this number isn't going to be really going to be important. Now we're going to take the water and we're going to boil it. And the first question I would ask you is, when we hear this water boiling, we know the temperature inside of this can is what? What is the temperature of water vapor inside of the can as it boils? Okay, that's my first question. My second question is, this can, the lid is open. So the pressure inside of the can is going to be equal to the pressure in the room. So how many kilopascals of pressure are inside the can? All right? Now, next thing we're going to do is we've got a raging boil. Listen to this. See the water vapor escaping? Okay, we're really on the flame here. So what we're going to do is take this and we're going to immediately cool it off by flipping it upside down into the water.
All right, 3, 2, 1.
Nice. This is what happened to our can, people. This is what happened to our can. So when we're thinking about this, it's not really Charles's law that we're using. Charles's law would say, well, it went from 100 degrees Celsius to room temperature. But that wouldn't, here, keep it crushed. That wouldn't explain this great a difference in volume. So the difference in volume comes mostly from the fact that the water was a vapor inside the can. Now, if we look at the can here, we can see that the can is 355 milliliters, all right? So this was a gas at 355 milliliters. So when we change it from a gas to a liquid, well, liquid water is much, much smaller than a water in vapor form. Let's think about water. How much does a mole of water weigh? Correct, 18 grams. And 18 grams would be equal to how many cubic centimeters? Correct. A gram and a milliliter and a cubic centimeter are all the same thing. So if we had a mole of water, vapor, how large would 1 mole of any gas be? Correct. It would be 22.4 milliliters. So, yeah, 22.4 liters. So the point I'm making is this 0.355 liters of gas would be much, much smaller as a liquid. And that's what happened. And the questions from your worksheet, or the questions that follow, those will be related to the crushing of the can. Here's our first question. The volume of water vapor in the soda can is 0.355 liters. Since the soda can is open, we know the air pressure is 101.3, and the temperature of the gas is 100 degrees Celsius because the water boils at 100 degrees Celsius. Use the ideal gas law, or PIV-NRT this, to determine how many moles of water vapor should be inside the can. Now we know how many moles of water vapor in the can. I need you to convert that many moles to grams. Okay? And since this 1 gram of water is a cubic centimeter, we know that the 0.355 liters of gas that had filled up the can have now crushed down to that many cubic centimeters.